Okay, so this is called a non-permissible value. Okay, tell me what in math don't we like about fractions that's not allowed in a fraction in math? What can't you ever do?
You also have a decimal.
Is this in the notes or in the?
It's in the work booklet. Okay, anybody figured out what can't you do in math with a fraction? What can't you do? You can't have 0 on the bottom. Don't like that. Okay, so when I look at this number 4, I don't want that to end up being 0. So what cos value causes a 0? Where are you if cos is 0? Right here? That's not good to be here. Or here. Okay? So I don't want to end up as the cos of pi over 2. I don't want to be that, or I don't want to be that. That's kind of the idea. I don't want to be that because that would equal a 0. That would equal a 0. Okay, but that's got a 2 in the front. So what angle would you have to double to make a pi over 2? Some kind of angle gets doubled and would end up as pi over 2. Or some angle that got doubled to be that. It ends up being this one. What angle would you double that ends up there? What angle would you be at that would double to that? That angle? Okay, so the angle pi over 4, if you doubled it, you would be there, and then you take the cos, and that's a 0, and then we would have a fraction with a 0 on the bottom, and that's not good. Okay, determine the non-permissible values. So, cosecant is the issue here. What is cosecant the flip of? 1 over sine of an angle. So what am I worried about? I'm worried about sine of the angle being 0. I'm worried about sine of the angle being 0. So where does that happen? So I'm looking at my unit circle. Where is a y 0? Right? Here and here. Okay, I'm worried about these spots, these angles. So pi, so 0, pi, and 2 pi. Because that's in my domain. Okay, I'm worried, number 6, about the bottom being 0. So what are we going to be worried about here? If cos of x is -1. Right? Because if the cos of x is -1 plus 1, that's going to make our bottom be 0. Can anybody find a spot on your unit circle that has an x value of -1? X value of -1? So the answer is pi. Okay, number 7. I would be worried about secant because that's 1 over cos. So I would have to look at that bottom and that bottom. So I don't want that bottom to ever be 0. So I'm worried about the cos of theta being 0. So where is that happening? Where is there an x value of 0? X value of 0? Here and here. Okay, so there's some answers. Pi over 2 and 3 pi over 2. Okay, number 8, the last one. I don't ever want to divide by 0. So I'm looking at this. I'm worried about it being -1 there, right? Because 1 plus the -1 is making that bottom be 0. So where is sine going to end up being -1? Where's a y -1? So there's your answer. 3 pi over 2. Okay? And the last one is on the flip side. So in that one, the secant is causing a problem because it's the flip of cos. And you don't ever want this to end up being 0. So where does that happen? It happens in those spots. So you could answer that one. That one would be a not allowed. Okay? So that's all we're going to do for that outcome. Okay, I did them all with you. I don't know how many questions you're going to see in some of the reviews in your tests and stuff, but just to kind of be aware of that thought process, that obviously you have to worry about math having a 0 on our division. What?
It's 1 plus secant x. So whatever cos can't be -1, which makes it 5.
No, that would be okay because that would be on the top. Like if you did 1 plus -1 as a number, it's 0, and that's okay.
Oh, okay.
Right?
Yeah.
It's just a division by 0.
Yeah. Okay.
So then if you had 1 plus 1 over 0,
Right.
that
Okay.
math would be a problem. Yeah. I think that's what you were thinking about there. If you did that,
Yeah.
making
Separate with
the number
one
0.
way.
Yeah. No, that was, I can see how to think like that.
Made sense. It's just
Okay, I'm going to flip to your notes now, and we're going to do trig equations, which we already know how to do. So I'm going to add, we're going to add one element on to how you did this last unit. So it's at the back, it's your very last page. Yes. Very last page of notes. Okay, we know how to solve trig equations. All this does is adds one line to the start of what we did last unit. Okay, I have my formula sheet here. Okay, so when I look at this, I'm going to replace formulas where needed. So the sine of b, that's normal. The sine of 2b is not something that I'm going to work with. So I'm going to look at my formula sheet and replace the sine of a double angle with the formula from my formula sheet. Okay, so looking at my formula sheet, this formula is the sine of a double angle. Okay, the only difference is this formula has an A, but ours is going to have a B in it. So I'm going to replace that with 2 sine B cos B. Okay, and that's the only difference this is going to be to from our last unit. That's it. Now everything we do is from our last unit. Okay, algebra branch. Do I have one variable? No, I have sine b's and cos b's. So I have 2 variables. What's the first thing you always do at 2 variables? What's the very first thing? Got to have it zeroed. Okay, so I'm going to move that. Okay, 2 variables, zeroed out. First thing we do is look, can we factor it? We have our 4 styles of factoring. Is it any of those? GCF, simple trinomial, complex or difference of squares. It's one of them. Which one? It is a GCF. So what can we take out of this unit and this unit, both? What could divide out of both of them?
Sine B.
Sine B. If we divide that by sine B, we get 2 cos B. If we divide this by sine B, we get a minus 1. Okay, if you struggle with GCF, make sure that when you multiply it back, it gets there. Okay, now I'm ready for my trig values. So sine B equals 0. Cos B equals positive 1/2. Okay, so this is all even grade 11 stuff there, right? Remember when we did that? Okay, now we're going to find the actual angle that does that. And we don't even have to use our calculator. We can do all this with the unit circle. Can you think about where this happens and this happens? And the question says to talk about it in degrees. It's talking about it in degrees. So where is their y values of 0? Right here and here. Okay, so I can have a 0 degree answer, a 180 degree answer, and if this was a provincial exam, because they like to trick you, why can't I have 360 as an answer as well?
Because it's not.
It doesn't have a greater or less than or equal to. Okay, so you can't write 360. That's it, done for that one. Cos B equals 1/2. So I'm on my unit circle. Where is the cos 1/2? Here, so 60 degrees. Cos is 1/2 here, 300 degrees. Okay, all last unit except for the first step was the formula replacement. Okay. This is not going to work with sine squareds and coses. Okay? Sine squareds and coses in a mixing into a equation is not good. Which one do you think I can make a replacement for? The sine squared or the cos part? We're going to pick sine squared. We're going to replace that. Okay, let's go to the top here. Okay, I find that a lot of people write this on their formula sheet. Sine squared theta equals what? How can I just manipulate those around? 1 minus cos squared. While we're at it, do you just want to manipulate these all here? If I want just cos squared, it would be 1 minus sine squared. What if you just wanted tan squared? Secant squared minus 1. And here I could also say cotangent squared. Okay, so you can take all that and maneuver it around so that you can have all of those plugins available. Okay? So I find lots of people write that when I give a test, they just write that right away, so those are just all ready to go. Okay, so we're replacing sine squared. So I'm going to replace it with this, 1 minus cos squared. Okay, that's the only thing new that I'm teaching you. Just the formula replacement. All the rest is algebra and trig stuff. Okay, so what I'm going to do now is do a distribution there, right? Just some algebra moves. Okay, now this is a point where I think about what to do algebraically. Well, I have two variables because I have cos squareds and coses. That's two different things. So equals 0. Which side do you want to move stuff to, the left or the right?
Right.
I'm going to go this way. And the reason is because I like my squared things positive. So do you see what I did there? I moved, and just for factoring's sake, I like my squared, then the cos squared stuff, then the cos, then the number. But I changed this, and I changed that sign. Obviously, I didn't change this one, right? Because it was there. Okay, the next would be, after we have a 0, can you factor it? That's my next question. So I'm going to try with a 2 cos and a 1 cos. So that's how to get that. Does it work if I put a 1 and a 2 or a 2 and a 1? Do you get something to work? You need a 1 and a 2 in those positions. What if I do a 2 there? Because that makes a 4 and a 1 there. Does it work out? 2 on the out, 1 on the in. So 4 minus 1 makes the 3. Do you see what I was doing? Outs and ins need that. So cos t equals positive 1/2, and cos t equals -2. Okay. Ooh, I like this one. Why do I like this one? No solution, and we're done. And we actually were just at this one, right? The cos of a half. But this time, we are needing to answer in radians. So we were just there. This is where we were. So now, pi over 3 and 5 pi over 3. That's it. Okay, so do you see how it's the same as the last unit? Okay, last one. What do you think we would replace? The tan squared or the secant? Tan squared. By the way, usually it's the squared stuff. You're replacing the squared stuff, and this is why, because all these formulas have squareds in them. Okay, so 2 times okay, we need to replace tan squared. Do you find it? We actually already wrote it out, right? So tan squared is going to be replaced with secant squared minus 1. Okay, so that's the new step formula. Okay, next, can you algebra some stuff here for us? Distribute. So this is got a lot of the same steps as the last question. I have secant squareds and secants, so that's into the two variables algebra. So I'm here, so I need a 0. Pick which side, and the squared term is the boss. So it's positive, so everything needs to move with it. It's the boss. So 2 secant squared minus 3 okay, this looks very similar to the last factoring, except for the 3 is negative. Okay, so I think from the last factoring, I think you have to switch your signs though. You guys, I did something wrong here. What did I do wrong? Anybody see my mistake? I did the wrong variable. I threw a theta in there. I marked some people off on their last test for switching the variable. Okay. Did you get your factors to work? Okay, so there, but this time I need a minus 3, so I'm going to put the minus as the minus 4 and the plus on the 1. Okay, secant t equals -1/2. Secant t equals +2. Okay, what do we do in an equation instead of working with secant? We're going to flip it to cos. Okay, so this is, we're very close to the last one here. So we'll do that one first. No solution on that one. Can't inverse that, it doesn't work. And we discovered where we were at a half. We were at a half there. But this says something different. It has solve for all. So now we go pi over 3 plus 2 pi k. So have to attach that, otherwise it would have been the same answer. Okay, I'm going to do one of them in your workbook with you so I can cut down some of your homework. How about? I'm trying to find one that is actually not on the unit circle. Oh, I found one. Number 7. So page 11, number 7, that would be a little bit different. We'll do that one together. Okay. Cos squareds, coses, and sine squareds. We have to replace something. Which item is going to get replaced? Sine squared. Ooh, this is some tricky algebra here. When you make that replacement, we're going to have to consider the subtract sign, right? Okay, so that's what I want you to make it look like. And I have it in brackets because I actually need to have it in brackets for a reason. Okay, so everybody found the formula from their paper? Okay, do you see why I put it in brackets? Because that negative sign is going to make that a plus cos squared, right? Does that make sense? Okay, so 5 cos squared so that probably would have caught some people. They would have just put it in there without the brackets. It would wreck. That sign would have caused the problem right there. Okay? Okay, ready? I'm going to now put those cos squareds just together. So 6 Okay, I think that we can factor this. We're going to try. I'm actually going to put the 1 and 1 on the outside, or at the last spot right now, because I know that's the only option there. Now you got to play around with what you need here. What makes more sense, 6 times 1 or 3 times 2? Looking at your middle number. 3 times the 2. And then plus minus is, how does that all work out for you? We need to have a minus 3 and a plus 2 on the out and in, right? Everybody's got their foiling process down there? Okay, cos angle equals negative 1/3. Okay, this one, wow, look at that. It's the same as our homework. I'm going to do this one quickly because it's a unit circle number. This is not, so it's going to be calculator work. Okay, so we know those spots. We've just done it twice now. And we need to talk about radian answers. So what did we have there? That was pi over 3 and 5 pi over 3. Okay, how do you do it when it's actually not on the unit circle now? We first determine Astica spots. Now we do calculator. Mode needs to get changed. Remember that? Change it to radians. Second cos, and again, remembering, don't put negatives in, right? The negatives in the location, not the math. 1.231. Okay, so I'm going to do pi minus that. Makes that angle 1.911. Okay, I got it back on my screen. Okay, I just took off another pi and then I actually changed it by -1. I always try to just maneuver it back onto my screen by adding, subtracting pi, whatever I need. Now plus pi. So this one is 4.373 because I don't ever really like to round until the very, very, very last step.